In this video, we will show how different regions of the electromagnetic spectrum are used in daily life and how mirrors and lenses form images that affect how we see and use light. This also shows how electromagnetic waves and optical devices such as mirrors and lenses work together in practical applications. In this video, we'll use a camera for our example and demonstration. A camera uses a variety of electromagnetic waves, primarily visible light for image capture and infrared or IR waves for autofocus system. The camera has a visible light of 400 nanometer to 700 nanometer. It is also near a UV light, which is 350 nanometer to 400 nanometer, and near an infrared 700 nanometer to 1000 nanometer. How does it work? In visible light, when a light from the scene reflects off the subject and is captured by the camera's lens, therefore, the sensor then detects this light and converts it into a digital image. Meanwhile, in an infrared waves, the camera emits pulses of IR light which bounces off the subject. The camera sensor measures how long it takes for the light to return, which helps it calculate the distance and focus the lens.
Light from the object enters to the camera lens. This lens controls how much light enters the camera and affects the sharpness and brightness of the image. The convex lens bends or refracts the light rays to focus them and form a clear image. This process ensures that the light converges accurately on the sensor for a detailed photograph. Then hits a mirror inside the DSLR body. The mirror is positioned at a 45-degree angle to direct the light upward toward the optical system. The mirror reflects the light upward to the pentaprism, which directs the light into the viewfinder, allowing the photograph to see exactly what the lens sees. The pentaprism corrects the orientation of the image so that it appears right side up and correctly aligned. When you press the shutter button, the mirror flips up, the shutter opens, and light hits the image sensor, capturing the photo. The sensor then converts the light into digital data which is processed and saved as an image file.
Now, we will demonstrate the camera and describe it.
Here's the description of the camera. Lens focuses on the light. The aperture controls how much light the camera needs. The shutter decides how long light hits the sensor, and then the image sensor captures the picture. Now, let us see how the camera works. Light passes through from the camera lens. Convex lens bends or refracts the light rays to focus them and form a clear image. The light then hits a mirror inside the DSLR body. Mirror then reflects the light upward to the pentaprism, which directs the light into the viewfinder, allowing the photographer to see what exactly is in the lens. Then, a mirror will flip.
A camera can help anyone. They're particularly used by journalists, photographers, and even scientists. They help because they can document events or discoveries and design better quality cameras, from professional cameras to smartphones.
Never point a DSLR directly at the sun or intense light sources because this can damage both the camera sensor and your eyes. Always use proper filters or indirect shooting techniques when capturing bright subjects to prevent permanent harm to your equipment and vision.
A camera has a built-in infrared blocking filter used to limit the infrared capture for standard photography, though it can be removed for specific effects. Interestingly enough, it uses a plane mirror and its lens system is a mirror and pentaprism mechanism which directs light from the lens to an optical viewfinder.
The camera shows the relationship between science and technology, showcasing how advancements can lead to powerful tools for documentation and creativity.